ESD, and products that are ESD compliant or ESD compatible, what does that mean? What we're referring to is electrostatic dissipative, because in a clean room environment, you want to make sure that you do not have operators that are hot, that will attract particles. And if the operator does attract particles, you want to make sure that the operator is grounded in a way so that they're a continuous loop, so that any charge to them gets grounded through the garment and is released through the feet. So let's start with an ESD shoe cover. What do we mean when we say when we have an ESD shoe cover? What we mean is that we have a carbon strip that's across the bottom of the shoe cover, so that when you put the shoe cover on, and I'll put this shoe cover on, and then I'll take the strip and I'll make contact with the strip with my skin under my sock. So the purpose of an ESD shoe cover or an ESD heel grounder is to take any static charge that's built up in your operator and ground it out through the floor, because clean rooms typically have a carbon fiber in the floor, and then the floor is grounded, much like homes in the Midwest where you have concern with lightning hitting the home. They'll put a lightning rod in the roof that goes deep into the soil to ground it. The same thing is true in a clean room. So the floor that you see in a clean room, not only is the floor conductive, but that whole floor is all tied together. Then a large copper line goes to the floor, and then that copper line goes to a big stake that goes into the ground. So basically what we're trying to do with ESD is we're trying to ground the operator. The best type of ESD handling to dissipate the charge is to conduct it out. And so there's two types of ESD products that we offer. One is conductive, and with conductive, here's an example of a conductive finger cot. And this is basically a latex finger cot. Latex is naturally an insulator. But when we take the latex and we load it with carbon, the carbon is conductive. So much like the black carbon in the grounding strip here, the black that's in the finger cot makes the latex conductive. That's not to be confused with a static dissipative. If you look at a nitrile finger cot, nitrile is inherently static dissipative, meaning that it will take the static charge and it will naturally dissipate it. The difference between conductive and static dissipative is the amount of charge and the rate of discharge. So generally, if someone is in a very static, sensitive environment, they're going to want conductive versus static dissipative. Actually, the more common solution now for static environments is to go to a full nitrile glove or to go to a full PVC glove, because both PVC and nitrile are static dissipative. And the advantage of having a full glove versus just a finger cot is you have more of a surface area that can dissipate or conduct the static away. How you test a product for its static effectiveness is with an ESD meter. Other things that are going to affect the static dissipativeness or the conductive ability of a finger cot or a shoe cover or anything in your ESD system is going to be the whole system. So temperature. The more humidity that you have, humidity helps conduct.